Right, good morning. Goedemorgen, very much, thank you. I know I'm probably the last person you want to see on stage here now, and we all wanted to see James. I know you're probably very disappointed, so was I. I was really excited, okay, I'm going to see James Coslin for the first time in real life. But unfortunately, it's not going to happen. There's a little silver lining to it. This talk was originally scheduled to be at the end of the day. So then you always have these difficult choices. Okay, am I going to do drinks? Am I going to do the last talk? Drinks, talk, drinks, talk. Well, now you can have both of both worlds. So we're going to have to talk now, and we'll still be in time for talks. For drinks. Sorry. Java. So, it's been quite a journey with Java if you look at all the versions that happened. And you can also see that at some point it really accelerated the versions. If we look here, then we can see between Java 6 and 7, there's 2 years. And then from Java 6 to 7, there's 5 years going on between one release to the other one. And the problem, have to stay here, huh? And the problem is, there were so many features which should be in there. There would be streams in there. There would be lambdas in there. They had the whole idea of this modularization of the JVM, this project Jigsaw. And it just took a lot of time. And releases didn't come out. Well, in the end, they decided we're just going to push Java 7 without all the fancy stuff I just mentioned. And then it took nearly 3 years to get Java 8 out. Java 8 was, of course, an amazing thing with all the streams and the lambda functions and the new datetime library. But still, it was 3 years. And then they said, okay, this Jigsaw thing, breaking up the JVM into smaller parts, we'll just push that to a new release, which still took more than 3.5 years. So at that point, I said, okay, we have to do something differently here because we need to push our releases to the market a bit more quicker. In the end, the way they were working was still very much this waterfall technique. We're going to push everything in there, and then we're just going to release it. And then they said, no, we're going to do this differently. From now on, Java is going to be a time-limited release. Every 6 months, we're going to push out a new release. And if things aren't ready, we're not going to have them in there. So shortly after Java 9, for which we waited quite a long time, we already 6 months later got Java 10. And another 6 months later, we had the first LTS, long-term support version, which normally lasts for 3 years. And that was Java 11. And ever since, we had 6 months releases of Java, which pushes new features into the language. And it's not just language features, it could also be improvements to the tools. It could be better JVM functionality. It could be better memory management, the garbage collectors. It could be the tools like the flight recorder. All these things are updated. And that has been going on until this September, where Java 19, which isn't even on this slide, was released. And the idea was always, we're going to have an LTS version for 3 years. And companies normally, they say, LTS versions, they're good, they're safe. It's tested functionality. We're going to put it in. We know it's not going to be preview features in there. So those are normally very stable versions. And then last year, when Java 17 was released, which is the current LTS, they said, no, we're going to change that. We're going to do an LTS version every 2 years. And that is really, really interesting because they really want to create a quicker adoption. Just as an idea, whom of you here is using Java 17 in production? Okay, counting down, I would say that's 15 to 20%. Who's on Java 11? Oh my God, what is the rest on then? Is anyone still on Java 8? Okay, well, still brave that you raised your hand anyway, so. Well, the good news is hopefully you will be able to quicker upgrade, because why is it so important to be on the latest version of Java? Well, next question then. Anyone here using Spring or Spring Boot? See, now we're getting the hands. Well, that's good, because if you just said, I'm on Java 8, but I'm using Spring Boot, great, because in the new versions of Spring, Spring Boot 3 and Java Spring 6, they gonna arrive the final, I think the release candidates are already out there, and they're gonna be final in like November of this year. And they take Java 17 as a baseline, so you can tell to your employer or to your chef, and you can say, sorry, can't do Java 8, can't do Java 11 anymore, because Java 17 is the minimum language level. And I think this is really cool, because it really forces us to use all these new features. Talking about these new features, after we had all this delay in the Java versions, a number of projects were defined. So we had Project Ember, and most of the things we're going to talk about today, I'm going to talk about today, will be coming from Project Ember. Recently, Project Leiden was started. Leiden. It's named after a Dutch astronomer. And Leiden is all about quicker startups for your JVM. It's actually, it seems like it's going to do something related to Grail VM, but not completely. Quicker startup times, warm boots, those kinds of things. There's Loom, of course, and Java 19 is going to show us virtual threads. There's 2 talks about it today, and really interesting stuff coming from there. There's Project Panama. If you want to connect to other languages, other devices, then Project Panama is really making use of more memory. It's really quite a difference. There's Project Valhalla, which we haven't seen much coming to the releases, but it really wants to use objects as simple data types, meaning it probably doesn't have an identity anymore, but it's so memory efficient. And there's ZCG, which is not a separate project, but it's all about garbage collection, because garbage collectors, I think, is one of the overlooked features of the JVM. There's so many out there, and I guess by default we're all staying on this garbage first G1 garbage collector. Right, so what features are we going to talk about tonight? Well, it's features that came between the previous LTS, Java 11, and the current LTS, Java 17. So think things like switch expressions, think text blocks. There's records, everyone's darling, if you're lucky enough to work with it. There is sealed classes, there's pattern matching, and those are all JVM features. All the things we're focusing on tonight is actually JVM or Java language things, except from the last one, because, well, you can't talk about modern Java and then not mention virtual threads. So there's going to be a little piece in there just as a kind of an appetizer for the versions, or the talks that's going to be later. Switch expressions. You might ask, why a switch expression? Because we had switches. I mean, we have a switch in language, has been there from day one. So why would we want to change that? Well, switch is really like a statement, right? And it is okay, but it has its drawbacks. You need to think about a few things. First of all, it's not so easy to test, because a function is much easier to test in isolation than a switch statement is. Another thing is that you have to remember, I can have one label and then a value and stuff like that. And let's not forget the break, which we always do, and things fall through. So there's really a lot to say for getting an improved version of the switch. And so the switch expression was introduced. And with this, you can now easily say it's going to be a function now, it's going to return a value. So technically this function here could just return the value right away, which makes it very much easier and safer to test. So how does it look? There's still a case label on the left, and then there's a value, the error operator, and then there is the value that is going to be returned. That's it. You don't have to do anything else. As you can see, there is no fall through, so you don't have to do the break thing anymore. You can have multiple values on the left side, multiple labels, where in the old select or switch statement, you really had to, okay, case label and then use the fall through to get to that value. There's one little thing to it, and that is that it has to be exhaustive, meaning every possible value should be covered. And maybe seems a bit painful now, but it really is very useful if you use it in combination with, for instance, sealed classes, which we're going to touch upon a bit later. The thing we see here is actually called a switch labeled expression. And because it was so cool, we actually got another one, which is a switch labeled statement group. And a switch labeled statement group allows you to do just that. You get to use multiple statements, and in the end, you will have to use something like the yield keyword to return the value. They really thought, okay, are we going to use return here, or are we going to use something else? In the beginning, it was just the last statement within a block would be the return value. In the end, it was decided to make it more intuitive by using the yield keyword. It still has all the features that the other switch statement has as well. So multiple labels, no fall through, and has to be exhaustive again. Right. The next, well, I don't know if you could call it a big improvement, but the next improvement that we got first introduced in Java 13 as a preview feature. And if it's a preview, you normally have to opt in with a command line flag. It got a second preview and became final. And text blocks. Well, what's the thing with text blocks? Well, first of all, I don't know if any of you have worked with Kotlin or Scala or even things like Groovy, which is quite an old JVM language. Then text blocks, I mean, having blocks of text was always there. I mean, we just couldn't understand why regular Java couldn't get it. But why? When would you ever need text blocks? Well, you're going to need text blocks, for instance, if you have some SQL in your code. And if you're using JPA and you got an SQL annotation, then it is actually quite nice to have. Another thing is, if you're using something like XML in your code, or you got a test class where you say, okay, I'm going to expect some XML coming from somewhere and I'm going to test it against this value. If you have to write it out, normally with all the fancy features and commas and semicolons, that's really going to be painful in regular Java. So here's an example of it. And so this is a very simple SQL, a very simple query. I mean, this could have been way, way bigger. And it still has a few things which are very painful. The first of all is you have to concatenate all these lines together, which is really just ugly and not very intuitive and doesn't really make you feel proud to be a programmer. Then we have these semicolons. And if you want to use semicolons in a string, then you have to escape them, and it just all gets very much uglier. And now, suddenly, with text blocks, we can do it like this. And that seems, at least to me, it is much more intuitive. Currently working on a project where we just recently moved some projects from Java 11 to Java 17. And I thought people are going to be really excited about records. They're going to use records now. That is so cool. But no, text blocks is really, if you have a lot of code and a lot of database code and a lot of this kind of queries or native queries. This is what people really like. So Java was perhaps a little late to the party. Or let's first point out how it all starts. It starts with a triple quotes on the first line. With that, you define this is a text block. And a text block for the rest is just a regular string like any other string in Java. So you can do everything. You can do the to uppercase, you can get the length, you can use it anywhere a string can be used, you can use a text block. 3 triple quotes, and for the rest, nothing on that line. And look, double quotes can just be included because suddenly it can be recognized, which is a really, really nice feature because it just tells you everything. A text block, again, ends with 3 triple quotes, and you can have it on the same line, or you can put it on a new line, depending. It has some implications, but basically you can use whatever you want. Then there's this concept of incidental white space and intended white space. The red area on the left here, that's actually something called incidental white space. You never wanted that to be there. You could have moved the text to left, but that would look really ugly in code, right? So probably just for formatting reasons, you had it here. Well, it might have taken Java quite a long time to get to this point, to support text blocks, but it actually does it in a very proper way because it recognizes this. The compiler says this and says, okay. Basically, you don't want this. You know what? You just leave it in code like this, but I'll move all the text to the left, as far left as possible, until something touches the left side, and then I'll stop removing those white spaces. So this will actually be completely removed. And then there's this piece where you decide, no, this is actually some formatting that I did by myself as a developer, and I want to keep that. And the compiler again looks at it and says, okay, I know what you're doing here. You know what? I'll leave it there for you. So it's very nicely formatted. So I think it's going to look really, really much better in code. Then, in Java 14, records appeared. And I think records were an instant hit. But either you love them, because there was this JSR, right, a Java specification request about it. And the idea about it is Oracle suggests, okay, look, this is what we're planning to do. What do you think? And people can have comments on it. And there were a lot of comments. Some people loved it. Quite a lot of people already hated it. But I think it's a great feature. Anyone here using records in their code currently? Still quite a few. That's very, very good. So what is records anyway? Well, it's a very concise, immutable data structure used for transferring data, actually. So if you look at a record, it looks something like this. Now this is something completely new. So suddenly, first of all, there's no longer the class keyword. That has been replaced by a record. And behind the record name, suddenly there's all these variables. So that is quite a bit different. And then at the end, as you can see, one back, there's just the braces and nothing else, no implementation, nothing. So what is going on here? Well, this generates a class for you. Again, the public keyword, you specify the final instance variables. We'll get to that in a second. And then the implementation. And basically you say, no implementation. So how do you create one? Well, actually, we're not seeing that here yet. What we're seeing here is we set the instance variables. They are final instance variables because records are immutable. So you create one, can never change it again. You can reassign it, can't change any of the values. So they said, wait a minute. So basically, they're read-only. Once created, so we don't have setters. So should we follow Java Bean conventions? Java Bean conventions saying, setters should always start with set location, and getters should start with get location. Or if it would be a Boolean, it would be is person or get person. And I said, well, why should we stick to Java Bean conventions? We don't have to. So they said, nah, we're going to do it differently. So basically, if you want to retrieve the value of an instance variable, you just use the name of that variable. So if I want to get the location, I can use simply conference.location. Creating a record is straightforward. Basically, you say, okay, conference is a new conference, and you provide all the arguments to the constructor. Well, you didn't write a constructor, so does it then not have like a default empty constructor? No, it has basically an all-args constructor, where every variable that you specified in the header of the record needs to get a value. A record by itself provides you with, like I said, a constructor, so the all-args constructor, the getters or accessors for the variables, and it provides you with the equals, with the hash code, and with the toString. So people very often say, yeah, well, that's quite nice, but I could just do a record, and I'll put a Lombok at all-args constructor and a at getter annotation on it, and I'll have the same. Well, yes, you would have the same, but not quite, because I'll show you why records are better and more concise. And it's pretty amazing that you can be more concise than Lombok, so that's actually quite impressive. There's also a thing which is called the shorthand constructor. Basically, if you would write a constructor, you would normally say, okay, public name of the record or class, and then name the variable name so that you want to use in the constructor. But records are quite easy because, well, you have to provide every instance variable in a constructor. So instead of replicating that information here, which would be just the same as everything after record at the top line, the compiler says to you, wait, buddy, I know which arguments you're going to pass in, because those are the arguments that you defined up there. So you don't have to tell me. So you can do these shorthand constructors where you can just say, okay, public conference, this is my constructor, and here you can do the validation of the variables that are being passed in. And you can still say, oh, this is not valid, and throw an exception. But records are not just all about being very short, being very concise. Records are also about security. And security in a way, say you're having a REST API. Data comes in via JSON, and you're using Jackson or GeeCON or whatever serialization library to convert the JSON to your data object. Can you be sure what's happening? Because basically you don't know, right? Because what is Jackson or JSON doing? Is it calling your setters, where your validation methods might be in? Or is it maybe using reflection to set the variables directly? You don't know. With records, you do know, because reflective access is not allowed. And the only way an instance like this can be created is via a constructor. So the record is all created at once, and it is guaranteed that you will come past your constructor with your validations. So this is a way more safe way to create. Okay, so that is one thing it has over the Lombok. And like we just saw, we can do it at the top. It's a one-line statement. Even if I would do Lombok, I would probably have to do something with, well, the name of the class, I have to define the instance variables, I have to define the all-args constructors, I have to define the getters. So definitely way less code. So records are really a great thing. So, next thing that happened was sealed classes. Sealed classes are a new concept to the JVM. And it's, in fact, to introduce it, it introduced quite a new set of keywords to the JVM. Why the need for sealed classes at all? Well, if you look at Java object inheritance, basically, you have two options, don't you? I mean, you can say, oh, well, this is my class, employee. Perfect, no problem. And that means basically if it's a public class and it's in that package, and anyone who has access to the package can subclass your class. The alternative is that you say, nah, I'll make it final. So, public final class employee. And just as we can't use the string class or subclass it because it is final, no one can then inherit from your class. Those are the two options, but maybe sometimes you want a more fine-grained access to your classes. Entering sealed classes. If you look at this piece of code, let's say we define a sealed interface. That's the new thing. You're now going to use the sealed word in front of your class or interface. Classes, interfaces, both can be sealed. And you say, okay, it's called plugin, and I allow a certain set of other classes or interfaces to inherit from me. So in this case, it would say, oh wait, I permit these other interfaces to, not so quick, to inherit from me. Great. So we have, remember those names, printer plugin, export plugin, user-defined plugin. Perfect. So if I would be a class any other than this, I would not be allowed to subclass it, and then I would get a compiler error. Now, if we move on, then we could do the export plugin. It was allowed, right? The export plugin was in the list. So the export plugin is allowed to implement plugin, and it says, you know what? I am sealed myself, because for subclasses there's three possible options. Option one saying, I am sealed myself, meaning I also have to specify who is permitted to inherit. Well, in this case, I'm saying, well, I'm only doing a JPEG export and a PDF export, so that's more than enough. So I think I'm happy with this. So sealed, and no one else can inherit. The second option is the one we've already seen. The printer plugin is final. You know, there's only one way to print this. I've got one plugin that will print it. No one else has to use the options from this plugin. So we'll mark it as final. That's option 2. And then finally, there's option 3, which says, I am non-sealed. And basically, you're breaking the whole encapsulation thing then, and suddenly anyone can subclass again. And though it might seem that the whole idea that you just had of limiting the number of classes to subclass is broken, actually it is not. Interesting fact is that this is the first hyphenated keyword in Java. It never had one like this before. So, how would we use that if we continue with the service? Basically, and now we're moving a bit on also to switch pattern matching, but basically we could write code like this, where we say, okay, I got an init method. For everything that implements the plugin, there's the init method. And then I'm looking at the plugin, and I determine, what kind of are you? Are you from the printer plugin? And basically this case printer plugin, that's a pattern matching, which we'll get to later, where it actually says, wait a minute, what type of class are you? And based on the type of class, I can return a different result. And here you can see that we can walk through these individual classes. And the cool thing, we're seeing a switch here, and where's the default? Didn't we always say like, oh, wait a minute, it has to be exhaustive. But because we specified the pattern hierarchy, the compiler now knows, oh, wait a minute, there's only like 4 or 5 classes that are allowed to subclass. And the compiler knows. So it won't bug you and say, wait, dude, where's the default case? The compiler knows. So that's really nice. That actually is not just nice for you as a developer that you have to write less code, but it's a kind of a guarantee that what you're doing is correct. Which brings us very quickly to the part of pattern matching. Pattern matching is a very old principle, but it's quite new to the JVM. And it was first introduced in Java 17 as a very, very careful feature. And the whole idea about pattern matching, it's not something that is on its own, but you can see there's an idea with records, switches, sealed classes and pattern matching, everything that goes to something like Brian Gutt's language architects calls data-oriented programming. Well, remember this class or this interface that we had before with the pattern matching, the plugin? Well, what if it has this init extended method? Things would then suddenly look like this. We would have a sealed interface saying, okay, and it has an execute method. Then I could have a non-sealed user-defined plugin that implements this plugin. And I could have an init extended method in there. Right, so this method only exists in a user-defined plugin. Now, then we could write code like this, where we say, oh, wait a minute. If plugin is an instance of this user-defined plugin, I need to do something extra. I need to initialize this plugin. And I'm doing that by calling the init extended method on UDP. And this is what pattern matching basically is. You have some kind of test, and if the test is successful, the results will be assigned to what are called pattern variables. In this case, UDP is a pattern variable. Kotlin people here would say, well, this is smart casting, isn't it? And it kind of is, just not completely, but it very much looks like smart casting. You don't have to write the cast yourself anymore. And that seems like a really, really, really small gain for something that was added. Oh, I don't have to do a cast anymore, but how often do I write those? Not that often, but it's just the beginning of the pattern matching. We'll get to way more pattern matching in a few minutes. Anyway, so it says here, okay, so plugin, you're an instance of user-defined plugin, so I'll call you UDP, and on UDP I can then do all fancy things that UDP is allowed to do. Great. Going back to the pattern matching for switch, this thing that we had before here we said, oh, wait, yeah, what kind of type of plugin are you? And depending on whatever you were, I can do things. And here you see pattern matching too, because the case statement here says, okay, the test that we're having here is you should be of the type printer plugin. And if you are, I'll assign you to the pattern variable PP. Same for export plugin, same for user-defined plugin. So that is how all these things work. Once they started with the instance of pattern, then I thought, oh, you know what, we're going to do a few more. And actually, basically, there are quite a lot of change requests out there now for using these plugins, pattern matching things. This one is called the guarded pattern, where you're saying, okay, I got an application, and looking at the switch statement, it's going to do something depending on its value. So first thing is this, it says case null, means if object, the OBJ variable, if it is null, then it will just say, okay, great, I can handle that. In a normal switch statement, switch expression, you would get a null pointer exception if you would use this as a switch statement, and it would crash your code. By default, actually, if you leave it out, it will still crash your code, because just to conserve backwards compatibility, if you're not checking for null and it is null, the compiler will actually insert a null check for you and throw a null pointer exception. Then there's this thing, and that is the guarded pattern. It says case you're a string, so your class type is a string, and if your length of the string, if it is larger than 10, then it will choose this selection. A little note on that, in Java 19, the double ampersand was replaced with the when statement, because they thought, nah, very many people probably see this as one statement, or with just, you know, a check for, and then they said, now we can, so in real world it now is called case string s and when s length larger than 10. Okay, if that wouldn't apply, because our text is like, the first thing, hello, is smaller than the 10, then it would actually do a match here. So it sequentially goes through all the possible things. So if you would have this one on top of the other one, then it would fail, because then it would never reach the second statement. So the order in which you provide them here is quite important. So then in Java 19, another type was added, the record pattern. If you remember this guy from before, it said, okay, there's the conference with the event name, the location, the date, and the in-person. Well, in traditional code, even if you would use pattern matching already, we would write code like this. If object is an instance of conference, then we'll put it to C, and then we can say C event name and C location. Well, record pattern matching goes a step further. Actually, it uses deconstruction, and new code will look like this. It will now say, if object is an instance of, and then I'll have to provide the complete definition of the record pattern. And once I've done that, it will get deconstructed into the variable name. So suddenly I can say event name plus in location. Now, that seems like a lot of typing for this specific part, but imagine you're having a larger piece of code where you say, okay, I'm getting this record in, and then I got 20, 30 lines of code where I'm doing all kinds of things. Then it would be much more convenient to say location than having to say object.location all the time, referring to the object. So that is what record pattern matching is for. There was talks about using array deconstruction patterns as well, but they're still in development, and I think they're still checking out what is useful there. And again, you can also use it in the switch statement like here below, where you say, okay, right, conference, so you can actually mix it to, oh, if the object is null, great. If it's a conference this type, I will do this. And by default, I'll do something else. Brian Guts, the language architect, he described a pattern in how all of these things we just saw, how they fit together, because we've seen all these individual changes where you can think, well, they're nice, they're nice things, I can use them in my code. But there's a bigger idea of how to use them together. Okay, this is the default. Well, let's assume the future interface. Everyone knows the future. We're kicking off some asynchronous process, and we'll have to call a get on it with either a time unit or not, depending if we want it to time out or not. And it can throw a hell of a lot of exceptions: the interrupted exception, the execution exception, or the timeout exception. And then if you write your code, you would get something like this, where somewhere in all this plumbing code, there's your business code with the future get. So not very, very, very fancy code. Right. A suggestion he had, what if we back then would have had the chance to use all the things we have now? Then we could write it like this. We'll say we've got a sealed interface, async return, which can either return a record with a success, a failure, a timeout, or an interrupter. So that's the 4 possible values. And they implement this sealed interface. And the async return would still give us the get method. Now then, suddenly we could write code like this, where we say, okay, let's call the future get, and it will return us one of the 4 possible types that we saw. And based on that type, I could use a switch function, and I can just say, okay, did it return this success record? Okay, then I'm going to do something with the result. Did it return a value? Okay, I'll have to do something else. Did it get a timeout? And I think this code looks way more elegant. And here you see pattern matching, records, and sealed classes all used in conjunction. He wrote another article where he said, well, Java is an object-oriented language, and there's nothing wrong with that. But more and more, our code is getting smaller. Maybe we're doing microservices or some cloud-native development, and we all know that suddenly we're breaking down the monolith, and we're going to use smaller classes and smaller code bases. And he said, maybe we don't need the complete idea of object orientation anymore, but we should more use data-oriented patterns. And this is why Java is moving in that direction. Right. And finally, we come to the current release of Java, Java 19, released September 15th or 14th of this year, which had some very cool features. Furthermore in there, of course, there was already record patterns in there, but virtual threads and structured concurrency, those were really the big hitters in that release. So, we're just going to go to 4 points, and then I'll leave you to the coffee again. What are platform threads? What are virtual threads? How do they work? And why do we need them at all? So, normally, threading in Java is actually quite simple. We have a number of threads, and they match perfectly one-to-one to the operating system threads. There's a few problems with that. One of it is that we just can't have that many of them, because if we get too many, they're quite resource intensive, or we'll just run out of memory. And that is one of the problems. Another problem is that if a Java thread blocks for an I/O operation, it needs to write to disk, it needs to write to your log file or whatever, it waits for a timeout period to happen. Your Java thread blocks, and in the process, it will block the underlying operating system thread. Now, I know that reactive programming tries to circumvent this problem, but I'm quite sure later in the talk on structured concurrency, they will explain you why maybe that isn't the best solution and why structured concurrency is way better. So there's quite a few backdoors to using a native Java platform thread on an operating system thread. So what are virtual threads then? Well, they still have the Java platform thread, which matches to the operating system thread. It is just that the virtual threads, they're managed by the JVM. And that means that one Java platform thread can actually have multiple virtual threads. Of course, not concurrent within the same thread, but it matches them. And basically what it does, if you look at this situation, we have the carrier thread, which is the Java thread, and it has we got three virtual threads in our system. So virtual thread 2 starts running. and it says perfectly, I'm doing my thing, and then it gets blocked for some reason. Now with normal threads, the whole thread would block, but not with virtual threads. The thing happening here is that virtual thread 2 gets suspended, and the JVM just looks, okay, anyone waiting here? And it finds out that virtual thread 1, VT1, is actually ready to be run. So it will place that on the queue, on the thread, and that one will keep running until it also gets to a waiting state for some reason, and then it selects the next one, which is virtual thread 3. And so it keeps on switching and switching. So the threads, the Java threads will always be busy as long as there are virtual threads. And there is no guarantee anywhere in your system that once you've started on the Java thread 1, that the virtual thread will actually get back to that same thread, which has some implications. But it makes way better use of the underlying resource, and the scaling is really out of the roof. Really, it is amazing. You can have like 1 million virtual threads in your system. And normal on my MacBook, I can have 1 million virtual threads. It will have no problem. And it actually completes tasks way faster than with classic threads. So it's really, really quite amazing work. So how do we use virtual threads? Does that mean we have to change our code completely? Well, luckily we don't, because there's a few ways to use them. The most easiest way is make a runnable and just give it to the new method in the thread class, start virtual thread. That's it. And the JVM will know, okay, you want to have a virtual thread, I'll do something different for you then, and I won't make a platform thread. The second option is, again, making a runnable and say thread of virtual start. There's also, of course, a matching thread of platform start method. And the third way, which is very likely something that you're going to use a lot, if you're going to use an executor service before, you would typically cache your threads, right? You would make a thread pool and all your threads would be in there. Well, virtual threads are never meant to be cached. So that's really an anti-pattern. You should never cache them. But we got a new executor service called new virtual thread per task executor. And you can just replace your pooled executor task service with this one. So your code changes should be minimal. Are there any implications on running your code? There's some things where it says if there's certain situations where maybe virtual threads could give a problem. If you use synchronized blocks heavily in your code, you might get into problems and you might have to rewrite that code. If you're just using it to get some smaller pieces of code, then it's really not so much a worry. And that was everything new in Java. So I think now it should be time to go to questions, if there are any. I could switch here, but I'm not sure if it's going to appear on the big screen. No, it doesn't. Stop mirroring is an extreme. I'm not actually mirroring. Oh, but there we are. That's definitely a good question. What happens if you have 3 triple quotes? Well, I'll probably say you made an error in your text yourself, because why would you have 3 triple quotes? The compiler will probably give you an error in this case, because it will see the 3 triple quotes, but you didn't end it with a semicolon. So it will then say, wait a minute, that doesn't really go. So it will give you an error. So yes, they haven't looked at this situation yet. That is completely true. And then the second one. In a text block, again, variable will be replaced by its value during a runtime. Values in the SQL where clause. There's actually a JCP, JSR for that, where they want to use something more like we have in Kotlin. I think in Kotlin is something with $/ or something, right? The string interpolation thing. They trying now to see if they can bring something like that in Java, but it is not in there right now. Now, what you can still do is that you can mark something. Let's say you put your text in there, and then you'll say, oh, wait, I'm putting here a dollar, var dollar or something, and then you can do a string replace $var dollar with the instance variables you wanted. So, so no, it can't do it right now, but there's workarounds where you can actually do it. Java 18, where is it? That's actually quite a good question, because I had made this table, and well, basically, to be honest, Java 18 was quite boring, because it really didn't bring much new things to the Java language itself. It brought something with garbage collectors and some JVM things, but it really didn't bring very new things to Java. So that's why there was nothing in there that was worth presenting. It brought some updates on pattern matching, but we covered that already. What's the trade-off of virtual threads? There is always some. Yeah, there's no free coffee, huh? True. And actually, well, first of all, it's a preview feature, meaning you shouldn't use it in production yet. You have to run the JVM with the enable preview feature, blah, 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 blah. And it's very, very, very new. And it is actually very, it's a complete new idea. But that's going to be a talk by, I think, David on virtual threads later, and there's also from the Helidon guys, Helidon Nima, there's talks, because Helidon Nima actually is using virtual threads. So I think these guys can better answer the problems, what the trade-offs are. I think in general it is very new technology. I wouldn't use it in production. Thread scheduling based on a certain priorities isn't possible yet. They're still developing things on that. My best guess is, but I'm not sure how the guys I just mentioned think about it. I think they want to have it stable by Java 21, which is in 1 year from now, and that's going to be our new LTS. So no more 3-year LTS versions. In 2 years, there's now 2 years between LTS versions, so Java 21 is going to be your next long-term support. You said virtual threads. No, it's gone. Do you have any comparison between Java virtual thread and Kotlin coroutines? No, I don't. and well, the reason for it is people hook to Kotlin. Well, I don't know. I really shouldn't be answering this question, because I think that is very much what the guys later. I really suggest going to their talks, because they can really better explain the difference. I think from a developer point of view, especially virtual threads matched with structured concurrency makes your code way more readable, which is exactly what Kotlin coroutines tried to kind of like make this branching code look sequential. Do virtual thread affect the way we use thread locals? Yep, it does. That's true, because suddenly you have way more threads, right? You can have like 1 million threads. But if thread locals are still attached to all these threads, then it's going to be enormous memory consumption. And for this, and I just have to remember, because they renamed it, but there is now a Java specification request for extend locals, which is another way. I think it has a different name. They started with extend locals, and I think it's now renamed. I just saw the pull request coming by last week. It's renamed in something different, but with virtual threads, you should use these extend locals. The only problem right now is that it is targeted for Java 20, so you haven't got it in Java 19. When is Java getting a null save operator? There's a lot of Kotlin people here, huh? I must admit that I once did this talk where we had a guy in Scala, and there was a Java guy, and I was the Kotlin guy. And it was the easiest talk ever to defend why Kotlin was, But I think Java's really catching up. And not everyone is allowed from their company to move to a different language. So if you have to stay with Java, and I think Java is doing a great thing, I'm not sure if we're ever going to get a null-safe operator. I guess if James would have been here, James Kotlin, we could have asked why the hell this null thing was in there anyway. So maybe it's a good thing he didn't come. You said virtual threads might have issues with synchronized blocks. Does it also mean they might have issues with thread-safe data structures? No, it only has to do with the way mutexes are used with the synchronized blocks, so it has nothing to do with thread-safe data structures. I think we can be quite safe there. You mentioned the security reason for records instead of using a class with Lombok annotation. What were them? Well, the problem, say you're having a class and you're going to deserialize this object, right? Which is in there, let's say it's just a name, a simple JSON structure containing a name. And you're going to serialize it on your class. Now, you don't know basically what the underlying code is doing. What is Jackson doing? Will it call, because you are smart. You said, oh, in my class, I got a set name, setter, and in it, I got a check. It can't be 0. If it's 0, I'll throw in an illegal value exception or illegal argument exception. Great. But then comes this, I'm moving away. So Jackson wants to say, okay, great, I'm going to call your class, I'm got this value in it. You're not sure it's going to use the setter, because basically it could use reflection, saying, oh, wait a minute, and via reflection I can set this value directly, bypassing the setter, thus bypassing your validation which was in there, and suddenly you could have an invalid value in that class, in that field. And with records, that would never work, because you always go via the constructor and you can have your validations on the constructor. How many operating system core threads are used to process virtual threads? Is that related to core count or just one? No, I think there's actually a system variable that you can set, but in general, it will use all the cores available. What is the use case for sealed classes? Well, one use case for sealed, I looked in the JVM and the source code for Java 19 to see if they would eat their own dog food. And yes, actually, if you look at the abstract virtual class, that's actually one of the few places in the JVM where they use sealed classes themselves. So that's the whole idea. If you want to limit the number of classes that are allowed to subclass yours. And of course you could say, well, it's my own library, so I'm in control and no one else can touch it. But of course they can still have access to it in one way or another. And if you can really make it hard-coded like that. So that's one advantage. The other advantage is that the compiler can think about things for you more, like we saw before with the example of this thread. Suddenly it knows, oh, there can only be 4 possible options. So it can really process those better. In production world, would we probably never choose other versions than LTS? Do you think LTS should be added more often? Yes. Well, there's 2 things to that. Yes, I think we only should use LTS versions in production, and yes, we should have them more often. They're now changing it from 3 years to 2 years, and basically getting it even further than 2 years. How often will you be allowed to change to a new Java version with some kind of implications, right? You can't say like every 6 months going to your employer saying, you know what, I think we should do the new Java because it's, sometimes you have to deliver some business functionality as well. So I think 2 years is a really good compromise. I'm really happy that Spring did the Java 17 thing. Java EE, on the other side, they said they took Java 11 as a baseline, which is not so cool, because that means by now you would be working with a 4-year-old Java version. Spring Boot 3 and Java 17. Is there any drama issues of using new Spring with Java 8 and 11? Yes, it won't allow you. It says basically you're not Java 17, I won't compile. So that's easy. So is there any drama? Well, basically no drama. There's nothing going to happen. Can you synchronize virtual threads? Synchronize virtual threads. Do they need synchronization? I'm not quite understanding this question. You mean if we still, because I want to be thread safe? Basically, the whole thing of thread is still working. Synchronization is kind of disapproved to use, and other methods to have locks are actually the way to go. So, but again, tomorrow or this afternoon you'll get the detailed sessions about those. Are you still aware of anyone still using Java 1.0? No, I'm not, but I used to be at a customer not very long ago where they still had Java 1.4, which means you don't have generics, and that's really, but they worked on really small IoT devices for entering buildings and stuff like that. So they just couldn't upgrade because there would way too much memory things. So yes, they still do it. Is pattern matching, is it always necessary to repeat the types of records and fields again? Yes, it is. That is really. What are the reasons for it? Well, basically, you're matching against a record, right? And that record could be any type. So it could have an employee with 2 or 3 different types of definitions, or and you still have to define how you want to call the instance variables in which they are deconstructed. Again, my example, really bad example, because then you don't see the advantage for a one-liner. Having 20 lines of code, I think it really makes sense. Can records be used if you have more variables, you have 20 plus? Well, that's the cool thing, because if you look, I think it's Scala, and in Scala, I think you can have a tuple and a tuple 2, tuple 3 with a different set of variables. Here you can have as many as you want. So that's basically what they're for. You can have as many as you like. What I didn't even tell about the records is they can implement interfaces. They can't extend any other classes. Makes sense, because then there would be no control, or other records. There would be no control over the constructors. Records are read-only. Does this imply we can use pointer equality in place of structural equality? Well, why would you use any of those if you just could use switch pattern matching? So I would just use that. That would be way better. Is new switch just syntax sugar, or does it compile differently than simple switch? Well, in the end, the bytecode isn't going to be very much different that is generated, but I think from your point of view, you get more safe code and more testable code. So that's the big thing. It's not that new bytecode instructions have been added to the Java virtual machine. Is there a plan to be able to destructure a record just for a few attributes? At the moment, not, because basically it's not just a name, it's also the name of all the instance variables that make up the identity of the record. So that's why we have to use those. Are there any performance hits? Oh, you're moving on. If you pass a list into a record, will the record still be immutable? No, underlying data structures will still be mutable. So yes. Are there any performance hits for using switch with pattern matching? No, it's not, because basically it's what the compiler does for you, because the compiler can really see, so it's done at a run compile time. So no, it is not. Is non-sealed and public class the same? Yes, it is the same, but you can't say a public class, because once you inherit from a sealed class, you always have to specify on any of the classes that it is either sealed, non-sealed, or final. Unless you inherit again from a non-sealed class, then it's open again. So once you use non-sealed, then it becomes like a public class again. That's correct. Text blocks are stored in string pool. Very good question. I have no idea. Can we deserialize records? Yes, you can, because basically deserializing is basically what we're doing when we're taking a JSON structure. Not sure if I understand exactly what we mean here. But a record can be written and read, so both options work. The only thing is, of course, like I said, you can't do reflection on it, so you can't have reflective access. So we don't need trim indent with Java text block like in Kotlin. I would have no idea what the trim indent does, but I guess what you mean is with the text shifting to the left and stuff like that. No, you don't have to. It took us 15 years to get it, but now it really works great. Do you feel that any of the features jump the shark, add unnecessary complexity to Java? Jump the shark, that's a cool one. Well, yeah, it is kind of new stuff. So if you're that's why the title was, this is not your father's Java anymore. Yes, there are new things coming to Java, but people have always been complaining that Java is verbose and old and not very modern in the way it works. And now we're adding new features, and now we're saying, God, this is getting complex. I think it's a good thing that the language evolves, because it allows us to attract great young developers like you guys here, and so that's only good. What's your take on GitHub Copilot? Well, if anyone can write my code for me, why would I be against it? So, since we have, how many questions are left, by the way? I'm looking at, I have no problem with answering them, it's just people might get really hungry. Since we have switch pattern matching now, what about switches for multiple variables? Takes pattern matching almost to the level of the comfort Haskell has. I can only say I don't think we have this right now, and I'm not so good at Haskell, but I know there's always one or two Haskell people that say, Haskell always does it better. So, but yeah, you're probably right. It is, I mean, Java is still this mixed language, and yeah. So no, nothing like that is really being planned. Will it be possible to manage context switching in virtual threads? Brilliant question. Please ask it this afternoon again. Why is using executor virtual thread considered an anti-pattern? Oh no, sorry. If that was what you got from it, then I was really bad at telling it. No, executor service, perfect. Virtual threads, never block them. That's the. Did I say block? Sorry. You should never use a thread service and say, oh, I'm going to use. So you use a virtual thread basically like you would. If anyone knows Go, in Go you got a method and you say, oh, I'll just method get customer, and if you want to make it, I'll be there almost. And if you say, oh, I want to stop it, then you just, I want to use it as a thread, you place Go ahead of it, and then it will run in a separate thread. And the same thing is here. So you use a virtual thread almost like a normal data structure. No need to buffer, batch, cache it. That's never cache a virtual thread. That's the thing.
Okay. 2 questions. Only those who has upvotes.
Only those who have upvote. Okay. Isn't switch kind of an anti-pattern? Is it not better to use polymorphism? Well, actually, if you look at it, we're using polymorphism together with the switch, because we're saying, oh, are you a plugin or are you a printer plugin or stuff like that? So we're actually using polymorphism like that, I think. But if you really want to explain it more to me or want to talk more about it, then we can do it afterwards. What is the point in a record pattern matching to repeat all the field names? I think we already said that. That could be different definitions, and you need to have a way how you're going to use the instance variables. I agree it is not the most elegant part of the system, but maybe one day we're going to love it. I don't know. Does runnable need to yield to be effective in virtual threads? Well, basically that's the whole thing a bit now with virtual threads. Basically, virtual threads now run, and they run until until they find, oh, something is going to block me now because I reach a timeout or I need to write something to a disk or something. And then they will hand off the work and the thread. And until then, it will take all the CPU and time it needs. That has everything to do with the fact that we're going to need schedulers, which should be pluggable in the new virtual thread system, but they aren't there yet. So basically, it runs until exhaustion or until it blocks. So you could use a yield and say, oh, I'm done. Well, but yes, I guess for now that would be a good way to do those things. Yes. Oh, then thank you very much and enjoy the rest of the conference.